Danny's going to take us through the learning roadmap for professionals, software development, and data science. Just before I hand over the floor to Danny, I would just quickly like to introduce myself. My name is Anuvrat. I work with Astrolabs. Astrolabs organizes meetups such as the one that you're attending right now. And at the same time, there are a lot of other different branches of business that we're in. So I would take you quickly, very quickly, I'll take you through it. Number one is the licensing and the co-working part of it, which is our office based out in JLT. The second segment is the Open Academy, which is basically what you're here for as well, the meetups and then the online courses that we do. The third aspect is the Astrolabs Talents, which is very new. We basically connect the right set of individuals to the right set of startups. And then we do corporate training. So if you're looking for a specific training for your company and you're looking to basically get in touch with someone, we would be the right person for that. So before any further delay, I would hand it over to Danny. And then if you have any questions, you can just drop your questions in the chat, and then we'll take it from there. And Danny would be mostly answering either as he goes or probably at the end of the webinar. Perfect, Danny, all over to you.
Thank you very much, Anuvrat, and good evening. Good evening. It's good afternoon, everybody. Welcome to this workshop. Now, this workshop is a little special because, unlike before, where we get into like the technical details, we're going to look at software development and data science more from the perspective of someone who wants to either learn these skills so that they can, improve their prospects, have a better career, essentially. Those or those who want to change professions altogether. So let's say you're in marketing, you're in sales, you're outside of these two particular fields and you want to enter, you want to transition to these fields. And third, it is for those who are already in these fields, but want to, let's say, look at different options for, let's say, evolving in their role, especially if you're someone who, you've had 2-3 years of experience in this role and you want to basically have a roadmap. That's what this workshop is about. So let me set up the agenda for you. Now, for those who are joining this session for the Coding Bootcamp, you have questions for the Coding Bootcamp because we have one coming up very soon. Stay tuned until the end, and I will talk about the Coding Bootcamp and something new that we're doing at Astrolabs. Okay, but coming back to the agenda. Also, before I talk about the agenda, I am sure that you will have questions. As I'm talking, as I'm touching on different points, you may have questions. Put them in the chat, and I will answer them. Like Anubhav said, halfway the presentation or towards the end, I will definitely come back to your questions. So here's what we'll do. First, we will look at the responsibilities that you will have to assume as a software developer. And we will look at the fundamental topics with which you have to be familiar throughout your software development career. This point will become clear once we jump into the slides. But both for the overview of software development and overview of the data science, we're going to stick to the, let's say, first principles. What are the things you should absolutely know from the beginning of your software development or data science career all the way to the very end? So this is not about libraries or certain programming languages, but essentially at the core, what is it that you need to really understand? So we will have an overview. We'll look at we'll have an overview look of software development, overview look at data science. Then we're going to look at some tips on learning effectively, especially in the context of software development data science. Okay, that will become what I'm talking about will become clear once we get to that slide. And then I will share with you some career advice. Okay, and like I said, even if you're someone who has no technical background, you don't even have a degree in anything related to these fields, uh, there will be some advice that I have to share with you also. Okay, so I suggest you stay tuned till the very end because there are at least two more things I want to mention, which I will get to at the end. Okay, but let's begin with an overview of software development. This is important whether or not you know anything about software development, whether or not you're currently in a software development role. So to get my point across, I want us to look at these 6 items. And we'll take it from there. These are perhaps the most important components, or let's say modules, in a computer science degree. If you've seen a computer science curriculum before at the undergraduate level, if you take, for example, the American or the Canadian bachelor's degree, you have 120 credits to complete, and each course is 3 or 4 credits. Many engineering disciplines share similar courses. Okay, so they all have to study calculus, they all have to study, let's say, chemistry, physics, biology, literature, maybe history, the basics. Not the basics, I mean, these are some general things that they teach every university degree, but especially when it comes to engineering, there's some overlap. The ones I'm showing you on the screen are the ones that are at the core of a computer science degree. Okay? And I will tell you why these are essential to a computer science degree, but also the profession of software development. And one more thing, I'm going to use software development and software engineering interchangeably. I don't want to get into definition, like terminology right now. So for the most part, when I say software developer, I mean software engineer and vice versa. Okay? Let me briefly touch on these 6 topics. And then we'll go on to the next slide, and I will put these 6 topics into perspective for you. Now, you can see the first item is programming. Now, this may not be surprising to you. I mean, everyone associates, computer science with coding. Okay, but that is a part of computer science. I would even say it's a small part of computer science, because there's a lot more to it. There's a lot more to this domain called computer science. So if you can think of computer science as this domain, software development is a subdomain of this bigger domain. So programming is obviously one of the things with which you have to be familiar, especially because you're solving computational problems using a computer, like the computer with which you're watching this workshop right now, your laptop, your tablet. Okay, so programming is number 1. Then we have data structures and algorithms. These 2 things go hand in hand. Data structures are these things where that you use to organize and assemble data that is stored on the computer. Now, this is a big topic. Obviously, I'm not going to go into deep detail about any of these, but I just want to make the point that we recorded a workshop like 2 weeks ago on this topic especially. So just remember, you can also check that out if this is something you want to check out. This is definitely something you want to learn deeply. This is something you want to deeply understand, the topic of data structure and algorithms. But this is something they will teach you in a computer science degree. And when you want to assume the role of a software developer, you absolutely must understand how data structures and algorithms work. I will touch on this maybe towards the end. I will come back to this particular topic because I'm sure you will have questions. But let's quickly go over these items. Yes, if you have any questions, like I said, you can either put them in the chat, but towards the end, I will definitely address your questions. Then there is discrete mathematics. Now, in any engineering discipline, we can consider computer science, if you want, an engineering discipline. Different kinds of mathematics are taught, like calculus, linear algebra, and so on. But discrete mathematics is at the very center of not just computer science, but computers, just the way computers work, from the hardware level all the way to the software level. Discrete mathematics is this mathematical discipline from which all of computational technology has evolved. So if you think about logic circuits, it stems from discrete mathematics. If you think about programming languages, they stem from discrete mathematics. If you think about, I don't know, computer compilers, it stems from discrete mathematics. Every single idea that you will find in the computer, from the hardware level to the operating system to the application to the web browser, all of those ideas have roots in discrete mathematics. I will come back. I will touch on this particular topic again later. But then we have computer networks. You know that when it comes to software development, there are different platforms. There are different computer platforms. You have mobile applications, you have desktop applications, you have embedded systems, you have smart devices like smartwatch, you have Bluetooth headphones. Now we even have running shoes that are smart. You have ATM machines, you have self-driving cars. All of these are examples of computers, and they're all, to some extent or the other, connected to the internet. In other words, you cannot be a competent software developer unless you know how computers network with each other, how the internet is functions. Okay, now the latter two, if you're a software developer, you don't need to know the next two in great detail. Because like I said, software development is a subdomain of computer science. Other subdomains include computer engineering. You know, these are people who work with or design the underlying architecture. So they need to know how operating systems work. They need to know how computers work, how transistors work. If I can ask everyone to keep their microphone on mute, so you can hear me clearly. Okay. Nonetheless, if you want to design algorithms and your focus is writing programs that are especially efficient, they're high speed, they consume low memory, then understanding at least how operating systems work can give you a big advantage. And computer architecture, at least understanding how the three main components of computers work together. Again, this is something we recorded in a previous workshop, but I'll touch on it very briefly. All computers, the ones I just mentioned, all computers have three main components: a processing unit, some form of permanent storage, and some form of temporary storage. The third one, temporary storage. If you want to be a competent software developer, if you really want to excel as a software developer, understanding how temporary storage works and how you can take advantage of the capabilities of temporary storage will take you to the next level. And this is the order that you want to follow. You want to start becoming a very good programmer, and then once you've attained a certain level of competence, you would move on to understanding data structures and algorithms in more details. So basically, you want to go from practical skills to more theoretical skills. Understanding theoretical skills is really important. And then you want to learn the mathematics, understand the mathematical notations. Because if you understand the mathematical notations, and this is something I will touch on again at the end, understanding the mathematical notation, it will unlock a level. There are certain, there's a varying degree of software development professions. Like if you think about companies like Google, the Amazons, IBM, and so on, there are certain levels. If you want to reach those levels, if you want to reach that kind of advanced level of programming, you cannot get there without understanding the mathematics. And the most important mathematics in computer science and software development is part of computer science is discrete mathematics. Now, one of the good things about discrete mathematics is that compared to the other ones, like compared to calculus, it's actually a smaller topic. You can actually fit this topic in one textbook. And unlike calculus or statistics, these are, by the way, some of these I will talk about. We're going to talk about these also when we get to data science. But discrete mathematics does not assume pre-existing knowledge. So if you're someone who says, I don't know calculus, I don't know statistics, any of that, great. Discrete mathematics is especially good for beginners. So I would highly, highly recommend that you put this on your list, put this on your bucket list. And I will share with you some learning resources at the end about how to get into this or how to start learning this particular topic. Okay. Now, let's see how these 6 topics fit in, or let's look at this, these topics with which you have to be familiar from another perspective. And that, of course, is the perspective of how the computer is built. At the very low level, we have the hardware, which is not even included on this in this diagram. But right above the hardware, the transistors, the physical CPU, the physical GPU, and the wires that connect these to each other, we have the computer architecture. So the computer architecture is, of course, where binary turns into electrical signals. On top of that, you have, let's say, the first layer of software, which is the operating system. And the operating system is the biggest piece. I'm not sure if the word piece is correct, but it's the biggest continuous form of software on any computer. The operating system is the most complex, and it's the largest software, form of software on any computer. And it doesn't matter what computer we're talking about, whether it's an airplane or an ATM machine or your laptop or your phone or with rockets, the operating system is the biggest software component. On top of the operating system, you have different applications, mainly desktop applications or native applications, right? If you think about Photoshop, Google Chrome, Microsoft Word, VS Code, the calculator, these are all applications that are running on top of the operating system. And then if you take one of these particular applications, which is the browser, then we can look at another level on top of that, and that is the web application. So these are applications that run specifically in the web environment. Now, why am I even talking about this diagram? Why am I even talking about these? If you are someone who wants to get into software development, or if you're someone who is let's say 1 or 2 years into a software development role, I would suggest learning these components, like trying to understand them deeply, top to bottom order. So if you're someone who doesn't know anything about software development, you've never written a line of code in your life before, start learning the top layer first. Get into web development first. And then gradually try to learn the underlying layers in more detail. Why do I advise you take this approach? For a few reasons. The first one is learning to program on the web is incredibly easy. Learning how to learn on the web is incredibly easy, especially if you take the programming language of the web browser, which is JavaScript. You can literally open up the browser right now. As you're watching this workshop, or rather when you RSVP'd to this event, you were doing it from the browser. You can literally fire up something called a console panel and start programming the web immediately. So you don't need to install any special software. You don't need to learn abstract programming concepts, which I will touch on in a second. You can literally start programming with the web. That is a great way to start learning software development. Why? Because just by learning to program on the web or learning basics of web programming, you're able to see immediate results. And then gradually you will come across certain programming constructs which are programming constructs that you should know or you will learn when you're dealing with let's say programs at the application layer, this layer over here. Okay. And then once you get into the application layer, once you start to look at programming constructs at the application layer, then you will come across other programming constructs that you will have to learn, and you will only learn these, you will only understand how these work when you get to the understanding how the operating system works. For example, if you take C++, C++ is a programming language anyone should know. It doesn't have to be the first programming language that you learn, but understanding C++ to some extent will give you a big advantage if you want to pursue software development as a profession. Now, C++ lives between these two layers. The Zoom application with which you're watching this workshop, Photoshop, Microsoft Word, Google Chrome, Mozilla Firefox, Microsoft, all of these desktop applications are primarily written in C++. If they're not written in C++, then they're somehow compiled to C++. So C++ allows you to, is this program language that allows you to talk directly to the computer hardware. So this is what I mean. This is why I suggest going from top to bottom. When you start learning programming on the web, and when I say learning programming on the web, I really mean JavaScript. There's no other programming language with which you can program the web. It's really JavaScript. Once you start learning the basics of JavaScript, the syntax is so similar to C++ that you can easily, once you're able to read JavaScript, you can start reading C++, but also other variations of C++. There is something called, C++ is one of the first programming languages. And its style is so popular that other programming languages emerge from it, including Python, JavaScript. There's a new programming language from Google, which is called Dart, Java, C#. These are all programming languages that stylistically or syntactically look very similar to C++. So this is the order that you want to follow. You want to start with web programming, which will open your, let's say, it will open your mind to new things which are easy enough to learn, But then as you start investing more time and effort into learning JavaScript, you will reach a certain point where where you're able to read, interpret, and understand the syntax of C++. And once you're able to read and interpret and understand the syntax of C++, you're then able to understand how operating systems work. And once you understand how the operating system works, and from there how computer architecture works, you will become a really sophisticated software developer. You will become very competent. Okay, let's move on. Now, I am sure you know that there are many technologies that and so many words are thrown around today. You have all kinds of programming languages, you have all kinds of frameworks, all kinds of libraries. You have React, Angular, MongoDB, MySQL, C++, C#, Xamarin, analytics, all of these jargons, and every day new terms are coming up. And if you're someone who's trying to get into software development, or you're someone who is into software development, but you're thinking to yourself, where do I go from here? The fact that technology is always evolving and there's always something new that is coming around can make you feel overwhelmed, and can make you feel uncertain. You think to yourself, there's so much I have to learn. Now, also when you go to when you look at job postings, if you go to LinkedIn today and you look at the requirements they want from you, the things you need to be familiar with in order to be qualified for the job, there's a long list. All kinds of technologies. Some of them you may have never even heard of. Never mind the fact that you don't know what they are. You haven't even heard of them. But here's how I would put it to you. You want to, going back to the previous slide and the slide before that, you want to focus on the fundamentals. You want to focus on the fundamentals. Libraries, frameworks, they always come and go. Cloud computing vendors like Google, Microsoft Azure, AWS, they're always evolving. One day this one is popular, the other day that one's popular. Today this one will become obsolete. The next day something new will arrive. In order to future-proof your career as a software developer, if you want to progressively keep on advancing and making sure that you're always going to be employable, then you want to come back to the fundamentals. Make sure you know the fundamentals. If you know the fundamentals, you can always learn how the next library or the next framework works. If today it's Angular, tomorrow it's React. If you know the fundamentals, then you don't have to worry about which library is popular, which one is unpopular. So rather than focusing on being a React developer, or or an Android developer or an iOS developer, focus on being a first principles developer, someone who knows how computers work at the core. So here's the approach I would suggest you take, whether you are a software developer currently or someone who wants to enter software development. Start learning the programming constructs. If you know the programming constructs, know them more deeply. What do I mean by programming constructs? I'm talking about conditional statements, like for loops, if statements, while statements. I'm talking about functions. Understand how functions work. In particular, understand the terminology related to functions like arguments, parameters, return statements. Understand the difference between variables, constants, and the different data types like strings, numbers, arrays, booleans. Now, I know I'm going through this quickly, but this session is being recorded, so you can always come back and watch this later. Then once you understand the programming concept, so once you understand how to write programs, if you understand programming constructs, then you can apply that skill to learn another programming language. So today, if you learn JavaScript, because you know programming constructs, then you can learn Python. If you want to learn machine learning tomorrow, because you understand programming constructs deeply, you will be able to write algorithms for machine learning. If you are a web developer today and you want to learn how to run applications for mobile, because you understand programming constructs so well, you're able to apply your skills or transfer your skills to become a mobile developer. Okay, this is again going back to becoming, focusing on first principles. Then you want to move on to data structures. Understanding the different types of data structures like trees, heaps, stacks, queues, all of these different data structures is essential. It's absolutely essential. If you, I don't know if some of you have, there was this popular tweet from the developer of Homebrew. Homebrew is a software that you install on Mac. It allows you to in an orderly way, install different programs in the computer. Long story short, this person who authored Homebrew once applied for a job at Google, and from his own the way he put it in his tweet, he said, I could, just because I didn't know how to reverse a binary tree, which is the type of data structure, they said, we don't want you. But he made the argument that, not knowing how that particular data structure works, it may not have been the most important thing, because after all, I built this very popular software. But when any job, whenever you apply for a job interview, they will almost always put you to some test where you have to demonstrate your knowledge of data structures, because it's so important. Choosing the wrong data structure can mean breaking or making the algorithm. It can mean making your writing program that is incredibly efficient or incredibly inefficient. So after you've learned program constructs, you want to learn data structures. And then after that, you want to learn something called object-oriented programming. So object-oriented programming is based on one topic within programming constructs, namely classes. So when you're learning about programming constructs, one of the things you will come across is called classes. And classes is a big topic within programming constructs. And in order to understand that, you would have to understand something called object-oriented programming. And then once you learn object-oriented programming, then you want to learn design patterns, the different ways you can write. You can combine data structures and programming constructs to write programs. You want to learn design pattern. And then you want to, of course, get into the mathematics behind computer science. If you really want to reach, like if you want to have a black belt, let's say, as a software developer, and you want to have an advantage over the many hundreds and thousands of people who are applying for the same role, learning discrete mathematics will take you to that level. And like I said, it is easy enough for someone who doesn't know mathematics to start learning discrete mathematics, and at the same time, it will allow you to think and allow you to appreciate the most advanced topics in computer science, including data science, which is something we'll get into right now. Okay. Now, data science. Data science is a relatively very new discipline. And let's try to see what is involved in data science by looking at it from a few angles. So data science is actually composed of three fields. Computer programming, I'm sure you've heard of Python, R, and different programming libraries. I will talk about that in a second. Computer programming is one of it, is one of the components. I won't say computer science because you're mainly focused on programming, not like as a data scientist, you don't have to know operating systems and computer architecture, computer networks. You don't really need to know how computer networks work, but you need to be a competent programmer. You need to know how data structures. Statistics and mathematics. This is the first thing that composes data science. It's the biggest thing. Mathematics is the biggest part of data science. Now, statistics is usually, they don't usually put statistics in the same basket as mathematics because statistics has more to do, it is obviously a mathematical discipline, but it also involves visualization and certain tools. So it's a little more practical than mathematics. But statistics and mathematics, you cannot be a data scientist unless you know this. You can. It doesn't matter how good of a programmer you are. If you do not know statistics and mathematics, you have no chance be getting into data science. But don't worry if this is something that if you're not good with mathematics, if it's something you're concerned with, stay with me. Let's get into the slides, and I'll give you a strategy for also learning mathematics really well. But there's more. There is not one type of data scientist. You have to also have a particular domain knowledge. So, for example, what is the domain knowledge? For example, you can be a data scientist in the healthcare industry. You can be a data scientist in the banking industry. You can be a data scientist in, let's say, the e-commerce industry. But you need to have a domain expertise. So you need to know the statistics and the mathematics. You need to know program, but you also need to know the domain in which you're going to apply these mathematical and programming techniques. So if you're someone who doesn't know statistics and math, if you're not someone who knows computer program and you're a working professional, then at least you already have domain knowledge. If you're someone who works in marketing, if you're someone who works in sales, if you're someone from the automotive industry, if you're someone in banking, if you're someone who is coming from healthcare, at least you have the domain expertise. All you need to do now is learn computer programming and statistics, which when I say that, it sounds like I'm making it easy, but there is a way you can learn these effectively, okay? It's a big field. Companies are endlessly and rapidly looking for people who can assume a profession, who can assume a data science role. But companies also want you to have domain expertise. So you already have an advantage if you're coming from outside of technology. Whereas someone who is in technology, someone who knows these two topics, must also learn domain knowledge. I will come back. I will touch on this more once we get to the slide preceding the last slide, when I talk about career advice. But this is what data science is composed: statistics and mathematics, computer programming, and domain knowledge. Now, let me tell you about, now within data science, within the data science domain, you have different specialized roles. So if you're a data scientist, you have a more particular role. You're either a data engineer, you're someone who actually has more of a statistical role. So a data engineer is someone who has a more of a programming role, is someone who maybe is more involved with cloud computing, whereas you have another role which is more mathematical in nature. You're someone who works with machine learning algorithms, someone who does statistical analysis, and then you have someone who is, let's say, in a more for lack of better word, a business role, like a business analyst, someone whose job is to take data and produce visualization out of it. But let me tell you about the 5 stages of data science process. So as a data science practitioner, irrespective of which specialized role you assume, you need to know these 5 stages of the data science process. The first one is first of all, you need to know what is the goal. Why are you even bothering with data science to begin with? What particular goal, what particular problem are you trying to solve? They can only be solved by the ideas and techniques in data science. But once you establish the goal, the next goal, and this is a data engineering role, one of the subtypes of a data scientist profession, you need to then collect the data, collecting the data from different sources. It can be digital sources from the computer hard drive, from the cloud, from flash drives, even physical papers or pictures. You will start harvesting the data, and long story short, you're supposed to put them into some kind of uniform or a homogeneous data format, like a CSV file, for example. Processing and analysis, the 4th and 5th stage, this is where you start to get into like really get into statistics and mathematics. This is where machine learning algorithms come into play. Processing and analyzing, and the goal is that you go from raw data. So the 5 stages of the data science process begins with raw data, and it ends with information. Okay, raw data. When you look at it, you can't make sense of anything. You cannot, for example, make a business decision by looking at raw data. So what you need to do is clean it up, organize it, apply statistics and probability theory techniques to it, so you can find some sort of pattern, and then based on that pattern, you can then make a decision. So you start at the beginning with raw data, and you go through this pipeline where at the end you end up with information, and based on the information, you can make decisions. So, for example, if you take a pandemic that we're dealing with the coronavirus, try to come up with a vaccine, or try to come up with, let's say, some sort of plan to keep people from spreading the disease, you would have to go through this these 5 stages. So irrespective of which specialized role you're going to assume in data science, you need to be familiar with these 5 stages. You need to know how they work. Even if you're not going to be working in all of them in great detail, you need to know how they work still. Okay. Now, we talked about how data science, in addition to requiring a domain expertise, you're required to have knowledge, deep knowledge of statistics and mathematics, and intermediate knowledge of programming. These 2 components are required to solve 3 kinds of data science problems. They're actually statistical problems you're trying to solve: clustering data, classifying data, and performing regression based on data. Clustering is, without getting into technical details, it's about organizing data. Classification is about, well, classifying data, putting it into meaningful, let's say, categories. And then regression, like the theme is about making predictions based on the data that you've harvested, the information that you've arrived at. And for clustering, classification, regression, these are the mathematics with which you need to be familiar. Now let's spend a little, like a minute or 2 talking about these particular topics. So if you remember the items I showed you for software development, they were mainly computers. We talked about data structures, programming constructs, computer networks, computer architecture, operating systems. When it comes to data science, as you can see, it's mathematics. It's just mathematics. Now, I would have included programming in here, but programming is, compared to how much mathematics you need to know, is insignificant. But here's 2 things I want you to know about this particular slide, or the mathematics involved in data science. Number 1, I will tell you how you should, the order in which you want to start learning these topics, and the different roles that these topics play in machine learning. Now, one more thing before we move, before I continue. When we talk about data science, the central component of data science is machine learning. Even if you hear about artificial intelligence and, self-driving cars, image recognition, identifying faces when you're looking at a picture or a video footage, all things automation, all of these are facilitated by a set of techniques called machine learning. In other words, at the center of data science is machine learning, and at the center of machine learning is statistics and probability. And all of the other mathematical topics that I've listed here, they are surrounding statistics and probability. So this is why you would want to learn data science, learn the mathematics and data science in this order. You want to begin with statistics and probability theory. these two go hand in hand. You cannot actually learn statistics on its own and then probability theory on its own. You will learn them together. So first you will begin learning statistics and probability theory. Then there will be some problems. There will be some operations that you have to perform. For example, if you're measuring probability, and the only way you can measure a probability is if you have you have to apply calculus techniques like differentiation, integration. So calculus, you can get away with basic statistics and probability theory without really understanding calculus, at least single variable calculus. But like I said, at some point you will definitely encounter calculus, especially single variable calculus. Now, again, I'm going to use some additional terminology and jargon as we go through slides. If it's going to seem overwhelming, don't worry. Like I said, this workshop is being recorded, and at the end of this workshop, I will share with you a reading list and a YouTube playlist, which you can, in your own sweet time, go through that and gradually learn everything we talk about here. But calculus you will need because it's very important to data science, especially at the beginning when you try to measure probabilities. You will definitely need to apply different differentiation integration techniques. And then linear algebra. Now, linear algebra, let's say it has two main subjects: linear equations and matrices. Matrices, vectors, tensors. The second part is especially important. The second, let's say, pillar of linear algebra is especially important to machine learning. Why? Because matrices are like arrays and objects in computer science. They are very important data structures for machine learning. So, for example, if you're trying to analyze an image, if you're trying to take a picture and, for example, try to examine the contents of that picture. Is it a face? Is it a man? Is it a woman? Is it a child? Is it an adult? Is he or she smiling or frowning? The information that is extracted from that picture is going to be put in a matrix data structure. So linear algebra is a study of manipulating and working with matrices. So if you want to apply machine learning, if you want to understand how machine learning algorithms work, then you have to understand the underlying data structure, which is the matrix. And a vector is a type of a matrix. So when it comes to linear algebra, you must at least understand the matrices part. If you don't want to bother with the systems of linear equations, then the matrix part you definitely need to know. So these first three, okay, and you want to go in this, you want to go left to right order. Now the below ones is once you want to get really advanced. Like I said, when it came to software development, I said how understanding discrete mathematics, understanding computer architecture, understanding operating systems will take you to the next level. Well, when it comes to data science, getting into the next three items will take you to that next level. Once you move past let's say basic or intermediate understanding of matrices, you then want to understand a special type of a matrix called the vector in great detail, because vectors they're essentially like, if you think about an Excel document, an Excel sheet, you know how Excel sheets have rows and columns? Well, a matrix can be thought about as an Excel sheet. But if you take one particular row or one particular column in that Excel sheet, that in mathematics we call that a vector. And this vector data structure is absolutely essential to machine learning. So, and it can branch off into a big topic on its own. So there's something called vector calculus. And then there's something called tensors. A tensor is an abstraction of a vector. So it has to do with vectors, the properties of vectors, and functions that have to do with vectors. It's really like we're getting really deep into mathematics from this point onwards. But I'm just telling you, I'm trying to lay out the journey for you, like what it looks like as you spend like 5-10 years into this profession. And then differential equations. Differential equations have special place in mathematics altogether. Why? Because every problem, everything that you observe in this world around you, from planets and stars and astronomy, all the way down to, for example, quantum mechanics, to I don't know how viruses spread, to how vaccines work, to how the financial market works, everything in this world, small to big, can be modeled with differential equations. So having some understanding of differential equations is always a good idea, always a good idea. Then differential geometry. You see now differential geometry. Let me try to keep it succinct. When you're dealing with probability theory and statistics, you're going to be visualizing your data. You're going to be visualizing them in the form of graphs and plots. And you want to be able to measure the areas and the surfaces underneath, or you want to basically measure the dimensions of your I don't want to use technical words, but you want to be able to measure the shape of your data points. So when you start plotting your data points, it will take on a certain shape. I'm sure you've seen like bar charts, or for example, bell curve. So those are shapes. When you start plotting your data on the graph, it starts to take on a shape. Now, certain shapes or certain probabilities, when they take on a three-dimensional space, you need special techniques to measure curves and shapes in a three-dimensional space. This is where differential geometry comes in. Now, I haven't put discrete mathematics in here. However, I would suggest that even if you don't want to, like, if you're someone who doesn't like application development or software engineering or anything like that, and you love data science, you can't wait to get into data science, I would also recommend you learn discrete mathematics. Why? Number one, like I said, it doesn't assume prerequisites. Like, for example, if you want to learn calculus, you have to know trigonometry. If you want to learn trigonometry, you need to know geometry. So you need to go back and learn the essentials before you can appreciate calculus. Now with discrete mathematics. Discrete mathematics, it's a great mathematical topic to start with for beginners. But all of the fundamental components in all of mathematics, all of the fundamental components in mathematics, like mathematical variables, mathematical functions, mathematical sets, set notation, for example, is used throughout mathematics. It doesn't matter which mathematics you look out, the fundamentals that are taught in discrete mathematics will be relevant always. Let me say this again. Whether you want to learn software development, or if you want to learn data science, or you want to learn engineering, or anything that has to do with mathematics, learning discrete mathematics will make you fluent in mathematical notation. Let me say this before we move on, because it's an important point I want to make. The challenge people have with learning mathematics is not the ideas, it's the notation. Now, I'm sure everyone here has, let's say, heard of the, like children's stories like the Red Riding Hood or the Boy Who Cried Wolf. Like even a 3-year-old can understand the story. Even a 3-year-old can understand the ideas in these stories. But let's say I were to give you this children's book. You'd be able to read it, no problem. But what if that book was written in a language that you do not understand? Let's say I'm going to assume no one in this workshop understands Japanese. If I were to write that story in Japanese and ask you to understand, you would say, I can't make out the characters. I don't know what's being said here. Like the ideas of the story are simple, but because you cannot make out the Japanese characters, you cannot understand it. That's the same thing with mathematics. In mathematics, the ideas are intuitive. They're really easy to understand. But the notation, the symbols that are used in mathematics get in the way. If you don't understand the symbols, then you cannot read. It's just like in English. If you do not know the alphabet, then you're not able to make out words. And if you cannot make out words, then obviously you cannot understand the message that's being communicated. This is why I suggest discrete mathematics. Discrete mathematics will introduce you to all of the alphabet of mathematics. You will know all of the notation. And like I said, once you know the notation, then you can learn statistics, you can learn calculus, you can learn linear algebra, you can even learn differential geometry. You can learn differential equations. Once you know the notation, then you will be able to understand the story. You'll be able to understand the ideas. It's perfectly possible, but you need to have a strategy. Okay, now I will talk about strategies in the following slide. And like I said, I will share some extra learning resources with you at the end of this workshop. I told you how to what you should start learning if you want to get into software development. Here's what you need to start. Here's how you should start learning data science. First, you want to learn statistics and probability theory. Now, it's a big topic, but you want to at least begin with the basics. So I want you to make a note of this. You want to begin learning about something called a random variable. Random variable and probability distribution. These two things, write them down, make a note of them, and start learning those two things first. They are at the center of statistics and probability theory. Random variable and probability distribution. But once you know the basics of statistics and probability theory, then you want to learn some programming. And in particular, Python and R. Now Python is a general purpose programming language. It's used in data science, but you can use it to program web servers and other kinds of applications. But R is specifically used for statistics. Now, why do I suggest you learn statistics before learning R or Python? Because you will be able to understand the syntax of R, but you won't be able to understand what you're doing with the programming constructs because you don't know the statistics. So, for example, there's a function for linear regression. There's a function for something called a correlation coefficient. If you don't know what that even means, then what's the point of learning R? So learn the basics first, then learn the programming with which you can do some basic statistics and probability theory. Now, let me also say this. There are two types. You can roughly categorize data into two types. There is discrete data, which a beginner can learn, and then there's continuous data. For continuous data, you want to learn single variable calculus. So calculus is a huge topic. There is single variable calculus, there's multivariate calculus. You also have differential equations, but begin with single variable calculus. And then after single variable calculus, you want to move on to multivariate calculus, which can involve matrices, which is why you want to start learning linear algebra. And then you can move on to multivariate calculus, and by the time you make it to the fourth and fifth item on this list, then you will have enough. You will have enough mathematical literacy to learn and understand other mathematical topics. Okay, now I know this may sound intimidating, and maybe even it may have surprised you. That when it came to data science, it was math, and only math. But that's what data science is. It's really at the heart of it, statistics, but done with programming. That's data science. If you can give it a simple term, that's how we define it. But you can learn these, and like I said, there are ways you can learn this. Now, The next two items that we're going to cover are some strategies I'm going to share with you for learning effectively, learning these advanced, very technical topics effectively. And at the end, the last item will be for basically, I'm going to give you some career advice, how to enter these fields, especially if you're from outside technology. How do you, let's say you started learning data science, you started learning software development, how are you going to gain employment in these roles? So I will talk about that as well. Okay. How do you learn effectively? Now, this is a big topic. I was not able to fit all of my ideas in this slideshow, but that's why I told you there's an extra learning resource that I will share with you at the end of this workshop. But here's the main thing that I want you to understand. How do you usually introduce yourself to a new concept? Let's say today you learned about the word or the term machine learning, or you come across a term called API. You come across a term called, let's say, big data. How do you go about figuring out what this means? What is the first thing you do? Where is the first place you start searching it? And I want you to answer and I want you to put your answer in the chat. If I right now refer to a particular term, if I say big data, where will you go searching for that particular term to understand what it means? So I can see Matthias says, Google the definition followed by YouTube. But does anyone, okay, so I'm going to assume it's safe to say that everyone does the same thing. If I can interrupt you for a moment, because I think my battery is about to die and I don't have a place to charge my phone. So if you give me 1 minute, let me grab my charger and I'll be with you in a second. Okay? Sorry about this, but the battery is going to die and we won't get to these important points. Let me just grab my charger and I'll be with you in 1 second.
Hey guys, till the time Danny is getting his charger for the phone, I thought I'd just quickly take you guys through. We're going to be putting up a link for a survey at the end of the webinar. If you're interested in knowing more about the other courses that we do, Danny will also speak about the coding course that we do at Astra Labs. So he's going to get into a bit of details about that as to what the whole agenda of the course is around. And then if you'd like to know more about it and about the other courses and things we do at Astra Labs, please just fill up the survey. It'll literally take you 1 minute. Fill it up, leave your details, and somebody from Astra Labs will definitely get in touch with you. So at the end of the webinar is when I will be putting that link up in the chat. And then, yeah, looking forward to connecting with everybody.
Perfect. Okay. So I hope that they take too long. Right. So now that we have battery, let's get into this. The topic of learning effectively, learning technology effectively. Now, let me first take you to this slide. This picture should resonate with you right now. The idea that there is this storm, this plethora of technical jargon and terminology coming at you every day. You do a Google search, and there is so much jargon, terminology, and you're not sure, which is which, what's going on. Say, for example, you go to Wikipedia, you're trying to learn for example, what is, let's say, machine learning. You open that particular article, and at the very first sentence or the first paragraph, you have 5, 6 links. They all go in different directions. And you lose track of what's going on. And what happens is you end up with more questions by the end of reading that particular article. You end up with having more questions than you had in the beginning. Now, let me take you back to the previous slide to get this idea across. So I hear Matthias said that he begins initially with a Google search, and then he proceeds onto YouTube. Okay, and I want to demonstrate something to all of you. Can I ask everyone to type in the next step they would do? Let's say right now, you want to learn machine learning. What is the first place to go to? Do you do what Matthias does? Do you first Google it and then go to YouTube? Or do you Google it and then move on to a book? Or do you go to a library? Please type in your answer. I want to demonstrate something to all of you. Okay, I'm going to start calling you out by one. So Alia, Ali, Amir, Asma, Ibrahim, Neira, Yusra. Tell me, what's the first thing you do when you want to learn? Let's say a new topic. So I can see your Google, right? But do you move on to YouTube, or do you go looking for blogs or articles? Okay, you know what? Okay, Asma says books immediately, right? But here's why I wanted to prompt you to answer me. The default assumption is that you will be learning when you try to learn something. Your expectation is, or at least your hope is, that you will start learning in a linear fashion. For example, you Google a particular term, you open the first search result, and you hope, or your expectation is, by the time you've finished reading that article, that you would have learned the thing that you're trying to learn. Or let's say you go to YouTube. You go to YouTube and you type in, for example, C++. And there's a video, 2 hours long, and you hit play and you put on your headphones, your earphones, bring yourself coffee, and your expectation is by the end of that particular video, you would have learned that particular topic. Or let's say not something even simpler than C++. The meaning of, I don't know, a for loop. Oh, sorry, I think there's some audio. Okay. Set up here. So we kind of, if we could imagine, if we could visualize our learning experience, it would kind of look like a progress bar, right? It starts filling up as you spend more time on it. So, and of course, all of us know that's not how it works. You open a video clip, halfway through it, you decide, you know what, this video is not explaining to me the way I want. You would jump to another video. Or like I said in Wikipedia, you're reading an article, halfway through the article, you have 10 tabs open from Wikipedia, and you said, you know what, this is too complicated. You draw back, and you either decide you come back to it tomorrow at a later time, or you say, you know what, this is too difficult. Let me try something else. Maybe I won't become a data science. I'll go into dentistry or whatever. And Asma says maybe taking a guided course would be great. Well, I will come to that in a minute. In reality, I would say that the learning experience looks something like this. If you look at my screen, every time you read an article, a blog, a book, you watch a video, maybe you go to a classroom and you have an interaction with a teacher or someone, or maybe a working professional, you're learning if we can imagine this rectangle being representing how much you've learned about a particular topic, then it would look something like this. For example, you will learn something about the basics, and then you would be introduced to something a little more intermediary. And then one or two things that are advanced relating to that particular topic. Let's say you're learning machine learning. But even at the beginning of your learning journey, let's say you learn statistics, you learn some calculus, but there are some gaps. There are some gaps missing in your, let's say, in your learning progress. What you want to do is, rather than jumping from article to article to article, or going to, for example, bookstore and finding this magical key, this magical book that will answer all of your questions, that will make you fluent, that will make you an expert, rather than going to, for example, enrolling in a course or subscribing to some kind of tutorial, or even attending, for example, a university course, and hoping that this box that represents your understanding will be blue by the end of that course, by the end of that book, by the end of that movie, by the end of the tutorial. You want to take a different approach. So why the problem is, you read that article, you watch that video, you're not satisfied with how much you've learned, so you move on to another video and you watch that from start to finish. Or you're reading a book, you finish that book, or halfway through the book you decide, this book is not doing it for me. You jump to another book and you have the same experience. You go from one book to the next book to the next book, and you're basically putting your hopes on the author, that the author will give you everything you need to know. You want to rather make yourself the center. You want everything to gravitate towards you. How do you do this? Rather than going from book to book to article, rather than trying to pin your hopes on a particular book or a particular video or a particular course, try to identify the gaps in your rectangle. Okay, I don't have a particular term to use, but let's say this is this rectangle represents how much you know about the topic. Try to find the gaps in your rectangle. What is it that you did not understand about the previous video? Maybe you were learning something about programming, and I understood for loops, I understood while loops, I understood functions. What the hell was a constant? So rather than jumping to another video that has to do with programming, laser focus on this particular term. What does constant mean? Now, once you focus on the gap, then you don't have to be worried about which book or which video or which publication you have to be concerned with. Just focus on identifying that gap and filling that gap. Once you fill that gap, move on to the next gap. And then let's say you've completed all of these gaps. The next thing is to add more, like progressively fill out this rectangle. So you move on to a new topic, something you haven't heard of before. For example, classes. Then once you read that article or once you're watching a video, some things you will understand, or most of the things you will understand, let's say, but there are some things here and there you're not quite sure. Let's say you're learning about classes, but you're not sure what an interface is. You're not sure what a constructor is. Again, rather than going back to a video, watching it from start to finish, or reading the book from cover to cover, just try to identify what is it that you did not understand about that particular topic. Laser focus on that and try to fill in that gap. So, and you will basically iterate over this rectangle. You keep going over this rectangle until you find all of the gaps and you filled out those gaps. That's the first point. So how do you go about this? Now, one approach, there are different approaches and there are different tools for this. I will mention one of them at least, but here's how you would go about it. First of all, let me get this out of the way. How many people responded with Google? Almost everybody responded with Google. And even if you don't respond, I'm going to assume it was a search engine. The problem with search engines, we don't have enough time for, I usually, in the coding bootcamp, I usually show this example to get this point across. But the problem with search engine is, search engine algorithms are designed not to show you accurate results, but they are designed to show you popular results. So for example, if you want to know the meaning of the word, let's say API, and you Google API, if you do this right now, if you do this, or if you do this after the workshop, I want you to do this experiment. Google the word API. You will find that the first search result, the second search result, the third search result give you definitions that are different from each other and conflict with each other. Did you understand what I said? When you Google something, especially if it's a technical term, the search results, the very first search results, contradict each other. And you will be left with more questions than you had before you even did the Google first. Because search engines are not designed to give you precise and accurate definitions. Rather, any page or website that is more popular, that will be brought to the forefront. Now, that popular website, they may be accurate, they may not be accurate. If you, for example, right now, you Google the word API, you will find that I think it may be the fifth or sixth result. It's from Red Hat, an actual, it's a cloud computing company. They're the only ones who get the definition right. Whereas the first, second, third, and the seventh and eighth, and the ones that come after don't get the definition right at all. Like they're not even close. So if you're someone who's trying to learn something for the first time, and you resort to search engines, you're going to be let down. But again, search engines are not meant to be an educational, they're not designed for pedagogy, they're not learning systems. They're designed, for example, to help you find, the best price for booking a flight, or top 10 places to visit when you go to Italy. They're not designed to give you accurate, precise definitions. So what do you do? What you want to do is so there are two things. Understanding things theoretically, there's theory and there's practice. When it comes to theory, when it comes to understanding concepts theoretically, for example, how let's say classification works in data science, or for example, what is the correct meaning of a class, or what is the correct meaning of the word API, you want to first resort to textbooks. And I mean university textbooks that are written and authored by university professors, people who know what they're talking about, not some blogger, not some tech journalist, an actual university professor who authored that book. And the way you want to approach this textbook is you don't want to go from cover to cover, because that goes back to the problem I told you about. Rather, you want to go to the very last page on the book. Let me show you something very quick. Let me just show you my PDF. Let me show this PDF reader. I'll show you this, and then I'll bring you back this slide. I just want to show you something very quickly. So rather than using search engines, here's what you want to do. Let's open up Acrobat. I'll make this point very quickly. Okay, let's take this book, for example. Let me share my screen again. Let me find one with actual index. Does this have it? Does this have an index? One moment, here we go. Yeah, this is the one. So let me share my screen. Okay. So here's an example of a textbook, right? This particular textbook is called, what is it called? It's called, Machine Learning Refined. It's a nice book. But rather than, so here's how you go about learning something new. Let's say you want to know a particular terminology, rather than Googling it, here's what you want to do. You scroll down, and you have your table of contents. You don't want to look here. You want to go to the very end of the book, where you have the indices, the index. And here are all of the terms. Every textbook has this. Every textbook has this index section. It usually comes after the appendices, after the appendix and the bibliography. At the very end, you have the index. And here's all of the terms. It's like a dictionary, basically. It's like a dictionary in the book. So let's say you want to know the meaning of, let's say, for example, gradient. You've heard of this word in data science and you go, what the hell is a gradient? So you go to the index of the book, find 2-3 books that are authored by, like I said, they're actually university like level textbooks, and they're written by professors, practitioners. Go to the index, and here, for example, they said the word gradient is on page 516. Go to that page. Okay, the linkings are working, but let's go to here, 516. Where is this? This is 516. Let's say here. Let's scroll down to 516. Okay, 516. I should have opened this before, but here we go. Page 516. I mean, this is how you would do it. This is how I'm asking you to do it. Here. And then here, you can see it says the gradient is a straightforward generalization. That's your definition. And you can keep on going of the notation of derivative of multi-input function. So here you can see the definition. In order for you to understand the definition of this particular term, you have to understand what this word means and what this word means. What this term means, what this term means. You do the same thing. You go, wait a minute, okay, it's something to do with derivative, but what's a derivative? So you go back to the index and you find out what the index is, what the word derivative is. If the book doesn't have the index, go to another book. Go to a book where this particular term is defined. And then you would do the same thing for the other word. What's a multi-input function? Go to the index, find it, and find it. And you keep on doing this over and over again until what have you done? You've filled out all of those gaps. So coming back to that book, coming back to the slides. Here's the algorithm basically. You find the term from the index, define the term. What's the definition? Then when you're reading the definition of that particular term, you will come across more definitions. Okay, zoom in on that particular term, define it. If that one has another terminology, define that. And then once you've completed, once you've found, like you have clarity about this, the most simple topic, go back up, make sure you've covered all the ground. Once you've covered all the ground, go back up again and cover the rest. This is how you essentially fill out this gap. So rather than search engines, use textbooks. Now, one more thing. You want to have at least 3 textbooks. Why? You have one textbook, it's written by like an expert on the particular field, but their definition may be a little different than the definition provided by another expert. So they may contradict with each other. Someone will say the API means this, someone will say the API means that. They both may be correct, but they're giving you 2 different perspectives. Or for example, the word gradient, which you just looked at. One author can give you a more clear explanation of the word gradient, another one not so much so. And you're stuck, and you go, which one is correct, which one isn't? This is where you would bring in a third book. The third book would tilt the balance in favor of this term or that term, because the book is going to agree with either one of these terminologies. So you want to have at least 3 textbooks for any topic that you're trying to learn. If you're trying to learn about programming constructs, try to find 3 good textbooks. If you're trying to learn about statistics, try to find 3 good statistical textbooks. And look at the definition at the index, then go to the other book and go to the other book and aggregate them. And that will be your definition. This is how you do it. Okay? Did I miss anything else? So yes, you want to do this recursively. Now, even as you're doing this, even as you're taking the approach that I have suggested, you will not be able to do this unless you have some sort of medium. I mean, like a paper, something on which you can take notes. You need to have, you need to create, let's say, a dictionary. Like you need to have your own dictionary. You know how we have an English dictionary with vocabulary? You need to have one of those of your own, like one that you wrote yourself. Basically, you want to think about the information that you're gathering, like some sort of building. You want to have strong foundation. You don't want to be uncertain about a basic term, move on to a more advanced term, and then move on to a more advanced term from that. Because if you don't understand the basics, then it's going to be like a building with a weak foundation. It's going to fall apart eventually. So what you want to do is two things. Number one, be absolutely confident about the definition of a particular word. And then once you're certain about the meaning of that word, then move on to the next and more advanced term. Now, as you're going through your learning journey, it doesn't matter if you're doing this in a classroom or you're doing this you're watching a video tutorial or you're reading on your own. As you're learning, as you're reading the textbook, as you're going to the index of the page, as you're Googling something, whatever, you need to immediately transfer what you're coming across on a piece of paper or on some kind of application. Basically, you need to have a map. If you've seen a mind map is a perfect tool for building such a dictionary, like an index of your own, a table of terminology of your own. Now, there are some tools. I haven't put them in the slides, but I will definitely share them in that document I told you about. But you can check that out there. The document will explain that in great detail. But it's important that you will actually have to have dependence on the tool, because when you're trying to understand a new topic for the first time, see, in psychology, they say that you can be conscious of 4 things at any given time. If you're, for example, thinking of browsing a web, if you're on Wikipedia and you open this link, you open this link, you open this link, you open this link, if it comes to the 5th link, your train of thought will fall apart. And this is where you get aggravated, you get frustrated, and you say, you know what, this is too difficult, I can't make sense of it, and you give up. So you need to have some kind of tool, even a paper will do, to keep track of everything you're doing. Now, a paper is not the best tool. There are some tools, like I said, those I will share later. Okay. Now, blogs, YouTube videos, online tutorials, they still have a place in your learning journey, but I would categorize them in the following way. If it's theoretical, if it's conceptual, like you want to understand it conceptually at the core, textbooks, hands down. Not even like those, there's this book called For Dummies, like linear algebra for dummies, calculus for dummies, not even those. You want to go to a proper university level textbook and search for terms the way I suggested, going to the index section. Okay, so make yourself the center of information. Don't depend on the book, make yourself in the center. If this book doesn't do it, discard, find another book. If that doesn't do it, discard, get another book. Find that book that defines that particular term specifically. Okay, but this is again in the context of software development, data science. Theory is part of data science and software development, but so is, you need to have practical skills. For practical skills, that's where you would watch YouTube videos. That's where you would watch Udemy or Coursera or edX or LinkedIn Learning. Now, I have a special comment about LinkedIn Learning. I don't have time to get to that, but I would suggest when it comes to online video tutorials, the undisputed champion is LinkedIn Learning. I will explain that, or I will. That's one of the things I will put in that document, which I will share with you later. But this is it. If you're trying to learn a concept, mathematical concept, programming concept, computer science concept, textbook. Don't bother with search engines. You will be disappointed. You will be misguided. Textbooks. But if you were trying to learn coding, if you're trying to solve, for example, a classification problem with R, Python, then you can go to YouTube videos like that. Okay. Now we are going a little bit over time, but I'll go through this very quickly. This is very important. So this is the slide I keep talking about. This is the section I keep talking about the whole time. Many people discourage themselves or don't even bother going into a technical profession like software development, like data science, because they say, you know what? I don't think I even stand a chance. I did not study computer science at university. I did not study engineering. I did not study this. I did not study that. How am I going to compete? How am I even going to stand a chance? Let me answer that question to you this way. The role, now here we talked about software developers and data scientists, right? These two professions are primarily technical, but they're not exclusively and only technical. There are at least 3 things you need to be competent at in these professions. Yes, they're technical professions, but you need to be good at communication. You need to be good at communication. If you're a software developer, you're not going to be working alone. If you aspire to work at a company, in a tech company, at a tech startup, you're not going to be working alone. You're going to have to be collaborating with designers, with project managers, with a client, with your peers, with your fellow software developers. Communication can make or break your career. And when you go to interviews, when you go to job interviews for software or data science, they're going to test you directly or otherwise for your communication skills, and of course project management. You need to be able to manage your time, manage your expectations, manage your manager's expectations, manage your client's expectations. Having these two is going to decide whether you'll be able to progress in your career or even have a career in these tech jobs, or get stuck in one role indefinitely. And I've seen examples where people who had deep technical knowledge, but because of the lack of communication skills, project management skills, they were left at the same job with the same salary. It did not have that fulfilling outcome that one would expect. So what does this have to do with you if you're not a tech person? If you're someone who comes from outside of the tech sector, if you're someone who's in sales, marketing, banking, healthcare, and you want to enter these technical fields, well, look at that. You probably already have these two. If you're a salesperson, you definitely have communication skills. Otherwise, you wouldn't be in sales to begin with. If you're in marketing or advertising, same thing. You have communication skills. And if you're someone who deals with clients directly and with the back end of your company, you have project management skills. So you're almost halfway there. If we're talking about a software developer role, not someone who just codes all day long, but a software developer, someone who does this professionally, or a data scientist who does this professionally, sometimes you have to stand before customers, before managers, before your CEO, and explain why you're going to approach this particular problem in this particular way, the costs and the benefits of the approach you're going to take. If you aspire to progress and have a successful career, these two, having project management communication skills, you cannot survive without these skills. So if you're coming from outside tech, you may not have technical skills, but you absolutely have the other two. So you're halfway there. And the technical skills, well, I will touch on that in a second, but you're not going to start from scratch. So if you're someone, I've had people come up to me and said, I'm in my 30s, I'm in my 40s, I'm in my 50s, I'm in my 60s, and you're telling me that I still have a I still have a chance. Of course you have a chance. If you've been 10 years, 20 years, 5 years into the industry, remember what I told you about data science? If you want to become a data scientist, you cannot secure a job unless you have domain expertise. And if you're someone who comes from a different profession, you have domain expertise. You have that important element. Same goes for software development. If you're going to be a software developer, what are you writing software for? You can't just say, hey, I want to be a software developer, I can write anything. No, you have to have a specialization. Are you a mobile developer, web developer, you're this developer? And let's say you're a social media app developer. You must have intricate knowledge of how social media works, how people communicate with each other. So there's more to these technical professions than just the technical aspects. And companies always want people who can come with these two skills. Now, one more thing. This particular slide applies to everyone. Whether you are someone who comes from a tech background, whether you're someone who doesn't come from a tech background, whether you have a degree in that subject, or you don't have a degree in subject. One of the now, even though this particular slide is in the context of software and data science, it actually applies to all professions in all industries. And in this diagram, so I want to come to some. I want to give you some background on this particular slide. Why am I going to talk about this? We have people who are university graduates, or they're even part of our coding bootcamp, or they want to join the coding bootcamp, or they want to do a university degree, or they want to switch careers, and they go, you know what? At this stage of my career, I'm well into my career, or I don't have a career, or I'm late in my career. I've been without a job for 5 years, for 6 years. I've been a mother, I've been a father. I tried to do a startup and I failed. All kinds of people with different backgrounds. They go, wait a minute. I complete this program. I learn how to code. I learn to do this. What are the chances I will have a profession? Do I even have a chance? The answer is yes, but one of their main concerns is the fact that some of them actually tried getting a job, but they had no success. For that matter, you have people who are in that profession, like they have a career, but they lose their job, or they want to go to a different company. 3 months, 6 months, 1 year goes on, they don't even get a response from the employer. There is a fundamental problem with how people go about finding jobs. Now, let me give you some perspective. Let me tell you why you should maybe give some weight to my opinion. I am someone who has received in my time as a software engineer, someone who has received unsolicited job offers from companies like Amazon, IBM, Microsoft, and even their other company, LinkedIn. So I'm saying this because I'm trying to make the point that I'm speaking from first-hand experience, and I have insight into how, especially tech companies, hire people. The way that companies hire, this is true for all companies, but let's focus on tech companies. When they want to fill a role, there's a vacancy in the company and they want to fill a role, they first begin by hiring internally. Let's say they want a managerial role, an engineering manager, for example. They look at their company, they go to HR, and they think to themselves, is there someone in our company who can fill this position? Forget CVs and any of that. They start with employees. They start with inside the company. Only if they are unable to find someone who is qualified in their company to fill in the role, they will go outside of the circle to their circle of connections. For example, if I'm a CEO of a company, I will WhatsApp my friend or send them a message, email, and say, hey, do you know someone in your company who could be a good fit? Do you know a friend, a family, a coworker, someone who can fill in this role? I hope you can see. I hope you can see where I'm going with this. If you basically companies will only reach out if they cannot find something within their inner circle. So if none of their connections are able to refer someone, it is at this point they will move on to recruiters, people whose job is to fish and hunt for professionals. And here's a hint: they go for people who are employed. Recruiters like people who already have a job. So I will leave it to you. I will leave this to your imagination as how you should craft your profile on LinkedIn and on your CV. They like people who already have a job. So keep that in mind. If the recruiter whose profession, whose full-time job is finding a person to fill in that role, if they are unsuccessful, it is only then that the company will pay attention to CVs. Now, the bigger the company, the less likely they will even leave this inner circle. The bigger the company, the less likely they will even leave this inner circle. So you can see how contradictory or how opposite each other they are, the employers in the company. Employees approach their employee from CVs, whereas companies don't even pay attention to people outside of their circle. They pay attention to their own employees, and basically they're going in opposite direction. So this is something to keep in mind. Now, maybe we'll have another workshop on this with the Astrolabs talent team, but you want to craft, or you want to have a certain strategy for applying to jobs. Out of all the different strategies, out of all the different tactics, the CV is the least successful one. The CV is the least successful one. Now, before we move on to the next slide, I do have some additional information about this particular part. The information I'm sharing with you, by the way, is from a very great book. I'm paraphrasing some of the information from the excellent book. So if you want the full learning guide, if you want a more detailed roadmap for software development, data science, along with the curated videos we create for you, and a more detailed guideline for how you should go about securing jobs in technology, just make sure to fill out this survey that we just that Anurag just shared with you. Okay, just make sure you do that because you don't want to miss out this information. And let me say this before I talk about this. If you're someone who wants to enter a job immediately, then you want to go looking for small new companies. So there are two ways you can take. If you have a dream job and it has to be a dream employer, you need to be prepared for that. You need to give yourself a 6 month, 1 year, maybe a window, or even longer than that. But if you're seeking employment because you need it immediately, then focus your attention on new companies, small companies. But this information in more detail is in the survey. Now, creating a strategy. One strategy is not going to work for everybody. The same strategy is not going to work for everybody. Some people have different learning preferences. Some people prefer to work alone. Some people prefer to work in groups. Now, what I'm trying to come to here is the coding bootcamp we've designed at Ashlab. So the coding bootcamp, you can think of something between learning on your own and a full-blown university degree. The program that we've designed at Astro Labs. Now, this is something you may want to consider, especially if you're decided, you're prepared, you've decided, you know what, this is something, and you've been thinking about this for a while, that you want to actually enter these professions. So the coding bootcamp is something you may want to consider. And this is the coding bootcamp in Astro Lab is the one based in the UAE, and it's currently the biggest in the whole MENA region. So maybe this may be something for you. This is something you may want to consider. So it's actually a 2-month program. It's a 2-month program, and it's designed, before I go into details, it's designed to take someone who knows nothing about coding and prepare them with enough skills, theoretical and practical, to gain employment, to have enough skills to secure a job as a software developer. It's called the coding bootcamp, but it's really designed to make you a qualified software developer in the span of 2 months. Now, 2 months is a short time frame, which is why this bootcamp is so intensive. It's designed for people who are serious, and people who said, you know what, I've done my research. I can see myself in this role. I'm passionate about it. I think I have a chance, and you want a properly planned journey with someone who can instruct, someone who can guide you, someone who can answer your questions in a timely manner. Because if you go at it on your own, you can definitely do it, but you have to be a little bit more flexible with your schedule. But if you want something, if you're serious, if you're ready to do this, and you want to do it in a fixed amount of time, I highly suggest that you at least go through the contents and the schedule of the bootcamp, so you have some insight. This is another way you can decide for yourself how you would go about entering these professions. Everything we talked about in this workshop, everything we talked about in the previously recorded workshop, which you can check on our YouTube channel, it's there, it's free. All of those topics, for example, the basics of coding, programming constructs, the basics of object-oriented programming, and essentially the skills you need to have to become a professional software developer. Those are the things we will teach in this coding bootcamp. The focus of this bootcamp is web development. Why web development? Because the previous slide I told you about. Of all the different platforms you can get into as a software developer, the web is the easiest. It is now also, and it continues increasingly become the most important platform. So out of mobile, out of desktop, the web is now the most popular platform. But it is also a good way for you to get into different specializations, like mobile development, desktop development. So you can check out the link, check out the calendar, check out the schedule, check out the testimonials, look at the people who have graduated from this program. If you can see yourself participating, you can reach out to myself, you can reach out to the Ask Labs team. We also have flexible payment options. You can pay in for installments. Check that out. If you're happy with what we talked about here, if it's something you've been thinking about for a while, maybe this is something you want to consider. Okay, and I hope you will have the opportunity to fill out the survey, because there is a lot more that you will find useful that we were not able to cover in in this particular session. And Urvat, if you want to come in,
sure. I would
tell them
just.
about.
Pretty much Danny's covered up more or less everything, but I just just would like to, as Danny emphasized as well on the survey, because it's important for us to know that you're interested in the coding bootcamp specifically, and obviously this is just like a quick sneak peek into what all modules will be covered in the bootcamp. So have a look at it. The link to the bootcamp, the landing page is already there. I've already sent you the link to the survey link. Leave in your details, and somebody from ASLab will definitely get in touch with you, and then we take it from there. And it's a great way to learn a lot within a nice stretch span of 6 months, 6 weeks, sorry. So yeah, that's pretty much from me. And anything else from you, Danny?
No, but I'm sure, but I think you may have questions because we talked about a lot of things and it's a lot for you to try to remember. But of course, you can always come back to the YouTube channel, watch the videos, and I encourage you to reach out to us because we do these open workshops all the time. We do them almost weekly. So it may be that what we try to, that your questions may be related to what we're going to be covering in subsequent workshops. And of course, about this bootcamp, if you have any concerns, then you can always reach out to myself and the rest of the Astrolabs team. But we have gone well over 1 hour and a half, which was the scheduled time frame for this particular workshop. I want to thank you all for joining us up until the very end. Thank you for completing the survey. We will be sharing those resources with you very soon. But until next time, I want to wish you a great day, and I will see you later. Okay, everybody? Take care and bye-bye.
Thank you, Danny. Thank you, everybody, for joining. See you soon.